Yay! Unit 2. We got 1 unit down, 12 altogether, so only 11 left to go. Lesson 1. Label everything that you need to label. Let's start with your vocabulary. We have equivalent equations, isolate, inverse operations, and then go ahead and group these. They give you 4 different vocabulary terms, but they are all properties of equality. Just understand that the properties of equality have 4 different kinds: addition, subtraction, multiplication, and division. Your definitions are, this one hopefully is pretty simple: equivalent equations, equations with the same solution or solutions. Isolate, which you know means to make something all by itself or lonely. In this case, in algebra, isolate is what we need to do with variables. We try to get variables all by themselves with a coefficient of 1. Inverse operations. Instead of giving you a long, wordy definition, I just said addition and subtraction are inverse operations. So are multiplication and division. If you have something being added and you need to do the opposite, you subtract. If you have something being divided and you need to do the opposite, you multiply. That's what inverse operations mean. Properties of equality basically means doing the exact same thing to each side of an equation makes an equivalent equation. Now, I'm betting that all of these definitions, upside down, are making you feel a little like this. They're kind of boring. They don't make any sense. The whole point of this is simply right here. If you know that x plus 3 equals 5, you can use your mental math at this point and figure out that x is equal to 2. What all of these definitions are helping you get at are the rules why, if I add 4 to both sides of this equation, so x plus 3 plus 4 equals 5 plus 4, x still equals 2. I have set up equivalent equations, this and that. I have used the addition property of equality to create equivalent equations. That's all it means. Let's move to the book. I am on page 81. They are giving you some brief examples of the property of equality as it refers to addition. Here's the fancy math rule. For any real numbers, a, b, and c, if a equals b, then a plus c equals b plus c, which makes me want to yawn. And then they give you an example over here. If x minus 3 equals 2, then x minus 3 plus 3 equals 2 plus 3. I wonder why they did that. Let's move on. The property of equality as it refers to subtraction. For any real number, blah, 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 blah. Take a look over here. X plus 3 equals 2. X plus 3 minus 3 equals 2 minus 3. I wonder again why they did that. Go ahead and turn the page. Page 82, problem 1. This is what I have been waiting for. I have been so excited. It was very hard in the last chapter for me not to jump ahead and go to like how you actually do this algebra. The last chapter drove me a little crazy. Okay, so what is the solution of x plus 13 equals 27? In the last chapter, you learned how to do a table, you learned how to use mental math, you learned several alternative ways to solve this. This is a very simple equation, which makes it a good example to learn how to do the real algebra. First, we have to isolate x, get it all by itself. But, you say, we have a 13 in our way. Well, we can do the inverse operation. This is x plus 13. You have learned that if we subtract the same thing from both sides of an equation, it is an equivalent equation. So, if we subtract 13 from each side of this equation, see, minus 13 here, minus 13 here, it's an equivalent equation. And 13 minus 13 gives you 0. So you have x left all by itself on this side of the equation. On this side of the equation, 27 minus 13 gives you 14. And that is how you really solve an algebraic equation. Now, what I just did was kind of important. If it confused you, stop the video, go back, watch it again. And if you think it's crazy how excited I am about this, you should watch what happens with whole tone scales. So, problem number 1A in your book. You know the routine by now. Either do it with me or stop the video and then check your work, whatever works for you, but this problem needs to be in your book. Y plus 2 equals negative 6. Well, we need to use the inverse operation so that we can isolate the variable. Aren't those all fun, huge words? So since this is addition, we need to use subtraction. And we have, whatever we do to one side, we have to do to the other. So that leads us to y plus 2 minus 2 equals negative 6 minus 2, which, poof, like magic, clears that out. We end up with y on one side of the equation all by itself and negative 8 on the other. There's one more step I want you to do. I want you to check your answer. Put this back in your original equation. Is negative 8 plus 2 equal to negative 6? Yes, it is. You did that problem right. Excellent. Skip letter B. All right, here's an example. Solving an equation using addition. Negative 7 equals b minus 3. Well, we can do the opposite of minus 3 by plussing 3 to each side. So negative 7 plus 3 equals b minus 3 plus 3. Got to do it to both sides or you'll end up with a mess, not math. The opposite of 4 equals b. Done. Go to got it number 2. Let's see how long it takes you to catch on to what happened here. So this is a, m minus 8 equals negative 14. So what do we have to do? Well, we have to isolate m, get it all by itself. So let's add 8 to each side of this equation. M minus 8 plus 8 equals negative 14 plus 8. Simplify that. M, because that cancels out, and then negative 14 plus 8 equals 6. So then, let's check it. Look at that. 6 minus 8 does not equal 14. I made a mistake. Did anybody catch it? I hope so. I bet Fabrice did. So then I realized I just forgot my negative sign when I solved it. So this is the right answer. That's the wrong answer. Letter B, 1/2 equals y minus 3/2. Well, this has ugly fractions in it, but the same principle applies. We need to get y all by itself, and this is subtracted. So let's add 3/2 to each side of this equation. 1/2 plus 3/2 equals y minus 3/2 plus 3/2. Those cancel out. That allows us to isolate y, and we end up with 4/2 equals y, otherwise known as 2 equals y. Check it. Does 1/2 equal 2 minus 3/2? Absolutely. That one's done. Time for the next step. Principle stays the same when we're multiplying and dividing. Here's your property of equality that uses multiplication. If a equals b, then a times c equals b plus blah, 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 blah. Here's a helpful example. If x divided by 3 equals 2, then x divided by 3 times 3 equals 2 times 3. Think about what that would do to this side of the equation. It's rather helpful. Same idea with division. If you divide each side by the same, they have to specify here, the same non-zero number, then you get an equivalent equation. Wonder what would happen if you used 0. That's a question for another day. Here's the fancy explanation. Here's the useful example. 5x equals 20. Well, if we divide both sides of that equation, I guess I should say if we divide each side of that equation by 5, then we end up with 5x over 5 equals 20 over 5. Think about what that does over here and how it manages to isolate our variable. Looking at got it number 3, letter A, the problem is 10 equals 15x. We need to isolate this x, so we need to do the inverse operation of this multiplication. And that inverse operation is going to be division. So we're going to divide each side by 15. Now, part of what I'm doing here is modeling what I expect your problems to look like. I expect to be able to follow your steps through so that I can see how your math is going, and if you have any trouble, I can figure out where you went wrong. So you work through this division, and you end up with 2/3 equals x, because those two 15s cancel out. We have isolated x on this side. 10/15 reduces to 2/3. Don't forget to check your answer. Is 10 equal to 15 times 2/3? Yes, it is. So you were correct. That was not so bad. Letter B. Similar problem. This time we have a negative number. Negative 3.2z equals 14. We have to isolate the z. So let's let's divide each side by negative 3.2. Make sure you remember that negative. Don't make the silly mistake I did earlier. The 3.2's will cancel out. We'll isolate the z, and then after you've used your noodle and figured out what 14 divided by 3.2 is, you end up with z equals negative 4.375. Problem 4 is very similar, except we're using multiplication instead of division. Got it. Number 4, same idea, except with these we're using multiplication. You'll notice I've switched back to a smaller writing utensil. I keep changing my mind on what's easier for you to read, so let me know if you have a preference. Problem A, 19 equals r over 3. Well, we have to isolate this r, but it's being divided by 3. So what's the opposite function of division? That's right, multiplication. So we're going to multiply each side by 3, because that will clear that denominator, and we will be able to isolate r. r is equal to 57. Don't forget to check that. Is 19 equal to 57 over 3? Yes, it is. Let's finish this up with, take a look at letter B. X over negative 9 equals 8. We need to isolate the x, which means we need to do something to get rid of that negative 9. So let's multiply both sides by negative 9. It should look like this. X over negative 9 times negative 9 equals x times negative 9. Multiplying by negative 9 on both sides of your equation. Those negative 9's cancel out. We isolate the x. We end up with x equals negative 72. Go ahead and check it. Does negative 72 over negative 9 equal 8? Yes, it does. Good job. On the top of page 84 now, problem 5, solving equations using reciprocals. This equation has a kind of challenging looking fraction in it. 4/5 m equals 28. How are you going to solve that? Oh, but wait! You remember there's some kind of wacky identity property as something or whoozy that we had to learn for the last unit, and you think, I can use the reciprocal! Because we need to isolate m. How are we going to get rid of 4/5? We're going to multiply it by 5/4, because we can do anything to this side of the equation as long as we also do it to this side of the equation. So multiply each side times 5/4. This cancels out. We're left with just m, nicely isolated on this side, and apparently 5/4 of 28 is equal to 35. Let's practice with a few. Problem 5, letter A. 12 is equal to 3/4 x. How are we going to isolate x? Well, we're going to multiply both sides times the reciprocal of 3/4. What is the reciprocal of 3/4? That's right, it is 4/3. So this is your next step. 12 times 4/3 equals 3/4 x times 4/3. The 3/4 and the 4/3 cancel out. We are left with an isolated x, and 12 times 4/3 is equal to 16. Check your work. Is 12 equal to 3/4 times 16? Absolutely it is. Well done. move on to letter B. It's an interesting problem. Are these two equations equivalent? Is m equal to 18 and 2/3 m equal to 12? How are you going to prove it? There are actually a couple ways to do it. One way is just to take this equation and turn it into this equation by multiplying both sides times 2/3. 2/3 of m equals 18 and 2/3. Simplify over here. 2/3 m equals 12. Those match up exactly. They must be similar equations. The other way to solve it is just to plug in 18 here and see if it works. Is 2/3 of 18 12? Why, yes. Yes, it is. We're going to skip problem 6 because you just have done math like that. That's not new to you. And I want to do something a little different. I don't want you to do the lesson check. I just want you to get some practice manipulating equations. So your homework is page 85, do 11 through 49, the odd ones, and please let me know how long that takes you to get done.